The first task is to show when the user is denied access to the main portion of the program. And there are two criteria which can lead to this. One of them is if the database isn't present. So this is the program's debug folder, and the database is normally located here. So if we take the database and move it to a different folder, and now try to run the program, they'll be shown this message, and the program will just close. If we move it back into the debug folder, and now try to run it, we'll be given access. This is the login form. Now if the user doesn't log in and just closes this, they'll be shown this mode selection screen. But if they try to press any of these modes, they will again just be shown the login screen. So the user is denied access to the main portion of the program if the database isn't present or if they're not logged in. The second task is to show how a user can register themselves. So this is the login form, and they can just press the register button down here. So here is the register form, and there are some tooltips here which help the user figure out how to register themselves. So here we can see names must not contain special characters, i.e. they must not contain numbers or underscores. They have a minimum length of 2. The username must contain only letters and numbers with a minimum length of 4. And the password must be at least 5 characters. So first off, let's just try pressing the register button now. We'll see that we've got an error message, all boxes must be filled. So let's just try typing into the first name box, and can't see if I'm actually pressing numbers and spacebar right now, which can be considered special characters, and it's not letting me enter them. So I'll type in Aaron Adams. Username, let's just say admin. Password, let's put in that. And security questions, and register. So I've still not filled in all the boxes. It's telling me that the passwords don't match and the security questions can't be the same. So we'll change that. We'll make the passwords match, and we'll give some answers to the question. Now we'll try registering. Okay, so all boxes must be filled, but passwords must be at least 5 characters. So and it's telling me that this username already exists, so I'll try to use another one. 2016 Adams A. And if I want to be a teacher account, I can press it here. For this student, I'm not going to need to press that, so I'll press register. And it's telling me I've been successfully registered. And if I go into the database now, there is 2016 Adams A, all the information, his hash password is there, and his information has been inputted into the quizzing table as well as his security questions here. The third task is to show how a user can reset their password if they've forgotten it or just otherwise need to change it. It's quite simple. On the login form, they can just press forgotten password here, and they're presented with this form. Now, if they just try to press reset password now, it says that all boxes must be filled. We put in a username, let's just say ASDFG. Press retrieve questions. The username does not exist. So let's put in the username that we just registered, 2016 Adams A, retrieve questions, and it says that we found the username. I'll now retrieve these questions from the database that we chose in the registration, and if we get one of these answers wrong, 124 Main Street, Bob, and try to put in a password here. That's just the passwords don't match. And now they're too short. So let's change that. And now we can try to reset the password, but one or more of the answers are incorrect. So let's change this to the correct answer, reset password, and my password has been updated. Now we can check the database, and this is the new password. The fourth task is to show how a user can be given access to the main portion of the program by logging in. Now, if they type in a string that's not a username into this username box and try to sign in, they'll be told the username does not exist. So let's type in the username of the user we just registered and type in a password, incorrect password, type in the correct password this time, sign in, and now we have access to every part of the program. This leads on to task 5, which is quite simple really, and it's to show the mode choice. I've basically just shown it, but this essentially allows the user to navigate between any of the modes. So they can press this and go to whatever they want, leave that, go here, look at this, and so on. It just allows them to navigate between the different modes. Task number 6 is to show how the simulation can be run, and the user can run the simulation just by pressing the simulation button in the mode selection screen. And this brings up this form. It's quite a lot to talk about here, but first I just want to talk about the interface. So over here is the lamp, and this lamp can shoot out photons, and there's a metal over here which has electrons on the surface which can potentially be emitted off. At the moment that's not happening because the photon energy is lower than the work function, and the work function is the minimum energy needed for electrons to leave. This colour here represents the colour of the light, and that is dependent on the wavelength. So if we change this wavelength, you'll notice that that colour changes too, and it can potentially be UV light if the wavelength is quite low. If we decrease the wavelength, these photons have more energy, which means that there's a chance for emission to happen here. And if we change the metal, which we can do here, to one with a low work function, then the difference between the photon energy and the minimum energy required for electron emission is quite high, which means that when emission is happening, these electrons are on average travelling faster because they normally have more energy. Also, the chance of emission is greater the greater the difference between the photon energy and the work function, because it means that not electrons just on the surface can be emitted. We can change the light intensity here, which changes the rate at which photons spawn. There's also a relationship here between the rate of photon spawn and the rate of electron emission, obviously because more photons are hitting the metal per second. The electrons being generated here have random vectors which have an upper bound which is dependent on the difference between the work function and the photon energy. The vector will only be accepted for the electron if the angle between it and the normal of the surface of this metal is not too steep and not too shallow. Task 7 is to show how the user can access the demonstration. Now there's two main ways the user can do this. They can either press the demonstration button in the mode selector, or alternatively, if they are in the simulation, they can just press run demonstration. And no matter what variables the user had the simulation set to have beforehand, once they press run demonstration, the variables are set to a default value. And notice how the user cannot change any of the variables themselves at this point. As the user presses the next button to run through the demonstration, it changes the variables itself and explains how changing the variables has an effect on the photoelectric effect. Now the user can follow this through to the end of the demonstration, or alternatively, if they get bored halfway through, they can press exit demo. Task number 8 is to show how a user can record experiment data in the simulation to see how changing variables affects these other dynamically generated variables. If we click on View Data, we can see all their currently recorded data. We can record more by changing some of these variables. You can see that these are calculated dynamically. Changing the metal also changes these variables. We can press record, go and view data, and that's been added here. And if we look at the database and refresh it, it's actually also been added here. That's where it's been taken from in View Data. So this is currently a student account, 2016 Adams A, which means that the student can only view their own recorded data. If we restart the program and log in as a teacher account, if we click on View Data, we can see the recorded data for every registered student who's recorded any data. Down here we can search for a user, so if we type 2016 Adams A, then only their data is shown. And we can press View All Users to return to seeing every student. Now if we enter a username that doesn't exist, or a user that hasn't recorded any data, for example, just adding a D on the end of that username, it will just return this message saying no experiment data has been found. Task number 9 is to show the functionality of the quizzing mode, which we can access by pressing Test Yourself and View Stats here. Now, if I want to do some questions, we can pick the number of questions here. Let's do 5 and press Start the test. Now, the question number is shown here and our ability level is shown here, and they're both updated after we finish every question. So we've got a question here, and the student can do some calculations to work out the answer to the question. If I give an invalid answer, such as just saying electron speed, well, that makes no sense because we're not saying what happens to it. If we press Submit Answer, we give them a message, please choose a valid answer. So the answer to this is actually the emission rate decreases, and we're told that that's correct. Our ability level increases there. The answer to this question is emission rate increases, but if I get the question wrong, for example, if I press no emission, I'm told that it's incorrect, and the correct answer was emission rate increases, and my ability level will decrease. Now, how much your ability level changes by actually depends on how quickly you answer the question. So the faster I answer a question, the more my ability level will change by. That goes for both increasing and decreasing the ability level. Now, if I go onto an account which has a higher ability level, so this account has a higher ability level than the one that we registered earlier, then we can see that there are more variables introduced into the question because there's a higher ability level, and so they're more likely to be able to answer this question. And the answer to this question is actually no emission, so I'll tick that. That's correct. And as I increase my ability level, questions will get harder and harder, introducing more and more variables. So 2016 Adams A now has an ability level of 10, so let's see what that looks like. So here we've got a question about colour. So like with an orange colour is incident on the metal, that changes from orange to green. The answer to that is the electron speed will increase. For this question here, the answer is the emission rate increases, but for the sake of testing, I'm going to say emission begins. And incorrect. Correct answer was emission rate increases, and my ability level will decrease. The final task, which is task number 10, is about showing the quizzing statistics. I'm currently logged in as the user we registered at the start of the video, 2016 Adams A, and he is a student account, which means the only statistics he has access to are his own. So he can only press View My Stats, and he's shown his ability level, the number of questions he's answered, and the number of questions he's answered correctly. And this comes from the database in the quizzing table here. So if we close this and sign in as a teacher account, we're given access to this button here, which is View Student Stats. This shows the stats of every student who's registered. There's a search box down here so that a teacher can search for a specific student's username and look at their statistics. So let's try and find 2016 Adam A, search username, there he is. Now this is using a binary search, and then the result of that binary search is used in a SQL query. We can then click View All Users, and all the users come back. And if we type in a username that doesn't exist, we're told about that.